Welcome to the Unit 1, Section 8 video on applications of inequalities. So just like we needed to learn how to solve equations so we can use it in real-world situations, we are going to now talk about how do we use solving inequalities in a real-world situation. So there are several key words that indicate which inequality is being used. For less than, we have words such as fewer than, smaller than, under, below, beneath. Of course, less than is included in that. For less than or equal to, you want to look for words such as at most, does not exceed, maximum, no more than, or up to. And then for greater than, we have more than, larger than, above, exceeds, or over. For greater than or equal to, you also may be worded as at least, minimum, or no less than. To solve a real-world inequality problem, you're going to look for keywords that indicate the operations being performed, such as the ones that you see listed here. Identify the variable. What are you trying to solve for? So again, this is, in most cases, what are you being asked for in the equation? Write the inequality that models the situation, solve the problem, and then express your answer with units within the context of the problem using a sentence. So in example 1, Rick won 17 tickets playing a game. To get a prize, he needs to win at least 30 tickets. How many more tickets does he need to win to get a prize? So we're going to let x be how many more tickets to get a prize. So our inequality is 17 plus x is greater than or equal to 30, because he can get exactly 30, or he can get more than 30 and still meet the requirements to be able to get a prize. Now we're going to solve it by subtracting 17 from each side, and we're left with x is greater than or equal to 13. So how do we write this in terms of a solution in sentence form? We can say Rick must win at least 13 more tickets. Example 2, Alex has $30 saved and he earns $12 per hour. He wants to have at least $150 in his savings account. How many hours should he work? So we need to find out how many hours that he needs to work. So that's our variable x. We know that he has $30 saved already, plus he needs to work so many hours at $12 per hour. So that's $12 times the number of hours he works. And that needs to be greater than or equal to 150, so he can have at least $150 in his savings account. So now we're going to solve this by subtracting 30 from each side and then dividing by 12. And that gives us x is greater than or equal to 10. So Alex must work at least 10 hours. Just as we talked about the solutions of equations needing to be reasonable, we also have to think about if the solutions of inequalities are reasonable. So once a solution to a real-world problem is found, it is important to consider whether the solution to the inequality is reasonable. Depending on the context of your solution, a decimal or fraction answer may not be reasonable. For example, you cannot have a fraction of a person or buy a fraction of a product. In those cases, we're going to need to do some rounding of some sort. So for example 3, bracelets are $3 each. Rachel can spend no more than $20. How many bracelets can she buy? So let's let x be the number of bracelets she can buy. So we have an inequality, 3x is less than or equal to 20. We'll divide each side by 3, and that gives us x is less than or equal to 6.6667 when it's rounded, okay? So she can't buy a fraction of a bracelet. So therefore, Rachel can buy at most 6 bracelets. We have to round that down because 7, she doesn't have enough money to buy 7. So she can buy 6, but she can't buy 7. So at most, she can buy 6. Jamie has $32. He starts shoveling driveways and earns $7 per driveway. He needs at least $75 to buy a skateboard he wants. How many driveways does he need to shovel? Well, let's find the number of driveways to be shoveled. He has $32 now, and we're going to add $7 times the number of driveways that he needs to shovel. So that gives us the left-hand side of our inequality, and that needs to be greater than or equal to 75 because the skateboard costs $75. So now we're going to solve it by subtracting 32 from each side and then dividing each side by 7. And that gives us x is greater than or equal to 6.1428. Now let's think about this. If he shovels 6 driveways, that's not going to be enough because it's got to be greater than or equal to a little bit more than 6. But he can't shovel a little more than 1/10 of a driveway and get that pay for that. So we're going to have to round this up to 7. He needs to shovel at least 7 driveways to have enough money to buy the skateboard. A taxi charges $3 and then another 75 cents per mile. Angela can spend no more than $20. How many miles can she travel in the taxi? So we're going to let x be the number of miles traveled. She has to pay the $3 fee plus 75 cents times the number of miles that she travels, and that has to be less than or equal to 20 because that's our total cost. So we're going to solve this, and we're going to use the method that I've previously mentioned of multiplying everything out to get rid of the decimal. So if we multiply everything by 100, 3 becomes 300, 0.75 becomes 75, and then 20 becomes 2,000. Remember, multiplying each side by 100 changes nothing. Both sides preserve the inequality because we're doing the same thing to both sides. Subtract 300 from each side, and then divide each side by 75, and we get x is less than or equal to 22.6667. So let's think about the context here. She can spend no more than $20. If she travels 22 miles, she hasn't hit $20 yet. But if she travels 23 miles, then she will exceed the $20. So she can travel no more than the 22 miles. We have to round this one down. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.